Hello everyone and welcome to the Safety Artisan, and today we're going to be talking about health hazard analysis. So this is task 207 in the Mil-Std-882E. We're going to cover purpose of the task, the description. The task helpfully defines what a health hazard is. So, task description. We need to evaluate the potential effects resulting from exposure to hazards. And this is something I will come back to again and again. It's very easy dealing in this area, and particularly with hazardous materials, to get hung up on every little tiny amount of potentially hazardous material that is in a system or in a particular environment. In the UK, when COSH, control of substances hazardous to health, came in the military. So we need to do, as it says, identification, assessment, characterization, control, and communicate hazards in the workplace or environment. So again, I come from a maintenance background. The operator often gets lots of attention, so that's a legitimate focus for human operator of a system, or pose substantial present or future danger to the environment. And there is an environmental task as well that is explicitly, maybe we need to define what we need by that. And then it goes on to specify that certain specific hazards must be included: chemical, physical, biological, ergonomic. And for ergonomic, I would say human factors, because when you look at the standard, what they call ergonomics is much wider than the narrow definition of ergonomics that I'm used to. So we've also got to think about hazardous materials that may be formed by test, operation, maintenance, disposal, or recycling. So what categories of information should this health hazard analysis generate? Well, first of all, it's got to identify hazards. What is the pathway or the conditions or mode of operations by which a hazardous agent could come into contact with energy or substances, concentrations, and so on and so forth. So I'm not going to talk about them further here. And again, I've talked about that elsewhere. Now, at this point, I'm just foreshadowing, we're about to move to talk about some different topics. And in particular, we need to think about what are we going to do with it when it comes to disposal, either disposal of consumables, worn out components, or final disposal of the system. But use, particularly over a long period of time, can alter those chemicals or introduce contaminants and make them more dangerous. Well, the human factors stuff gets buried in various tasks, and we don't identify a separate human factors program with all of the interconnections that you need in order to make it fully effective. So under this task description, we need to think about mission scenarios. So apologies for the gendered language, but that's the same. So this is really very broad once we get into the cognitive arena, thinking about what are the operators going to be doing, and exposures to mechanical stress while performing work. How might the designed work or the designed equipment induce human error? And what does that imply for human exposure? Well, this is this bit. This is part A and B. So we're thinking about, well, if we stick people in a vehicle, whether it be a land vehicle, marine vehicle, an air vehicle, whatever it might be, because we're going to have to keep those records for a long, long time. So again, very demanding recording requirements for this task, because of course, if we load people up with protective equipment, that may introduce further hazards. Maybe we're making the individual more likely to suffer a musculoskeletal disorder, or maybe we're making them less agile, or reducing their sensitivity to noise. And then we need to look at, the trade-offs. When and where is it better to equip people or not to equip people and limit their exposure, or just keep them away altogether. Radiation is always going to be dreaded by humans, so we might be doing a superficial analysis, or we might go overboard on a particular area. And I've mentioned hazmat, but there are many things that people can get overexcited about. Maybe the analysts don't understand them or don't want to know. So we need to think about all of these things and ensure that we don't have an unfocused analysis that as a result is ineffective or wastes a lot of money looking at things that don't really matter, that are irrelevant. In part F, there are 29 references which the standard lists, which are all US military standards or US legal standards. And we've also got ergonomics. Actually, strictly speaking, we're talking human factors here because it's a much wider definition than the definition of ergonomics that I'm used to, which tends to be purely physical effects on a human. What do we need to specify in order to set up whatever medical monitoring program of the workforce we might have to bring in the future through life? And indeed, we will often be directed as to how we are to calculate and estimate stuff. But this is a good example of how you might have to do it in another country. But when we come to the end and we have to demonstrate compliance with Australian requirements, if we haven't thought about that explicitly up front, so they mandate certain approaches, they mandate certain exposure standards. So we've got codes of practice on hazardous manual tasks. So potentially there is a lot of regulation and codes of practice that we need to follow. And remember that COPs are, while they contain regulations, they also are a standard that a court will look to if you get prosecuted. And that should be broad and as thorough as possible. And also, you should be doing task 203, which is a system. But where we need to do specialist analyses, we may need to find specialist staff who are competent to do this kind of unusual or specialist work and do it well. So if you can think about this early and engage people early, then you're going to get better support. You're probably going to get a better deal, because in my experience, if you call in the experts and ask their opinion early on, they're more likely to come back and help you later. They don't need your work because that you're not a priority in their eyes. So we dread them. We get very emotional about this stuff. And I've seen lots of programs spend literally millions of dollars analyzing stuff to death, which really doesn't make any difference to the safety of people in the real world. So we need to use that risk matrix to understand what is the real level of risk exposure to human beings. Now, having said that, there are some exceptions. We do need to think about accident survivability. So what stresses are people going to be exposed to if their vehicle is in an accident? So that may be a very significant thing for your system. And also post-accident scenarios in terms of very often a lot of hazardous materials are safely locked away inside components and systems, and we need to sort of clean up the site afterwards and so on and so forth. So maybe we need to get in some specialists to give us advice on that, or we need to look to some standards if it's a commonplace thing in our industry, as it often is. You know, we learn from bitter experience. But also there's lots of free resources on the website as well, and there's plenty of free videos to look at. So that is the end of the session.